All right, we have 2 more lessons in this chapter. This next one, still about parallelograms. Okay, we're still dealing with parallelograms. This is, in fact, I believe our last section on parallelograms. Tomorrow, we're going to do something different. It's just not a parallelogram. It's still quadrilateral, still 4-sided figure, but they're not parallelograms. This is our last couple of parallelograms we're going to use. In fact, let me come over here and let's grab one. Actually, nope. I can just make one easy. No, sorry. I do want to get one of these. Let's get this one right here. That looks like a parallelogram, doesn't it? And let's put that right here. Alright, this is a parallelogram. Because of the way I drew it. Not because you know, because they haven't given you any information about this, have they? What can you say, just with this just sitting in front of you right now, what can you say about this thing? What would you say, David, that this thing is? Quadrilateral. Okay, it's a 4-sided figure. Okay, that's all you know about it. But what if I told you this? Let's do this. What if I told you that this side was equal to that side? Can you tell me anything more about this right now with that information? Okay. Well, no. With just that information, you really can't say anything else about it. But watch this. If I do this, actually, I lied. What if I did that? All 4 sides are equal to each other. Why is it a parallelogram? Is that what a parallelogram says? If all 4 sides are equal, then it's a parallelogram? Say it, Connor. Good. Both pairs, let's say it that way. Both pairs of opposite sides are equal to each other. Would you agree? Look, these are opposite each other, they're equal. These 2 are opposite each other, they're equal to each other. So, guess what this thing is then? It's a parallelogram, isn't it? Alright, so this thing is a parallelogram. So what's true about a parallelogram? Well, the opposite sides are also parallel to each other, right? The opposite angles, what's true about the opposite angles? No, just the opposite angles. This angle and this angle. Since it's a parallelogram, what's true about those 2 angles? You guys are dead today. What's going on? They're equal to each other. What about these 2 right here? They're equal to each other. Alright? Now, I'll tell you what. Let me get rid of all that stuff. I'll keep the sides on there. Because what I'm going to do now, it's a little bit different. Well, the first part of it's not, because we've drawn diagonals before. And we're going to draw them again. So that part's not different. Okay? But let's take a look. Remember on a rectangle, what was true about the diagonals of a rectangle? We talked about that earlier in that last problem that we just went over. What was true about the diagonals of a rectangle? Michaela, what's true about the diagonals of a rectangle? You're just going to shrug your shoulders and say you don't know? Javon, what's true about the diagonals of a rectangle? Brooke, what's true about the diagonals of a rectangle? They bisect. Okay, but of a rectangle, not just a parallelogram. That happens, they bisect each other on every parallelogram. It would be really nice if I say things 3 or 4 or 5 times in a row that people would listen at least one of those times. That would make my day, it really would. We said this earlier when we went over that problem. Okay, we had a rectangle, and I erased it all now, but I had a rectangle, and what did we say about that the diagonals of that rectangle? They were what to each other? Joe, help me out. They're equal to each other, that's right. The diagonals of a rectangle are equal to each other, okay? That's something that you have to know. You can't just sit here day after day and not hear what's coming out of my mouth, all right? It's got to sink in at one point. It's not that hard. The diagonals of a what are equal to each other? A rectangle. Is this a rectangle? No, it's not a rectangle, okay? So, are the diagonals equal to each other? No, they're not. It is a parallelogram, so what's true about the diagonals of a parallelogram? They bisect each other, that's very true. So, I'll tell you what, let's just do this in a different color. I'll just still use the 1 for this, 1 for this, 2 for this, 2 for this, okay? But watch this. Here's something special about, oh, by the way, I didn't even tell you the name of this figure. This right here is a quadrilateral with 4 equal sides. It's got a special name. Here it is. It's a rhombus. Okay, you might have heard of a rhombus before. I really doubt that you've done a whole lot of stuff with a rhombus in the past, like in middle school and stuff like that. You might have mentioned it and said what it is, but you probably didn't do a whole lot of stuff with it. Now we're doing a whole lot of stuff with it. Look at this. I've got the diagonals of a rhombus. They do bisect each other, but the diagonals of any parallelogram bisect each other. What does it look like? Just to your eye, what does it look like they do? How does it look like they hit each other? At a center, we've never really talked about the center, but what kind of angle do you think is formed here?
A right angle.
A right angle.
Is
Actually,
the H in rhombus silent?
yeah, you just say rhombus.
Rhombus?
Yeah, it's not rhombus. It's just rhombus. All right, I guess it could be. I don't know. Maybe it originally was rhombus, okay? I have no idea. But we just say rhombus nowadays, all right? The H we just don't pronounce, okay? Or you could say rhombus. Or how would you say it? Rhombus. I don't know. All right, anyway. That's a right angle right here. So let's write a little thing. These were the diagonals of a rhombus. Give me a good, solid geometry word about the diagonals of a rhombus. They are what? One word. One single word. They are, say it. Perpendicular. Very good. They are perpendicular. Let's write that down. That the diagonals of a rhombus are what? Perpendicular. Okay. Now they're not equal to each other. They're only equal to each other when you have a rectangle. Okay. But on a rhombus, they form a right angle. Okay. They're perpendicular. So that means it's a right angle. So what kind of triangle do we have right here? This one right here. That's a right. That's a right triangle. Okay, I know you were. This is a right triangle right here, isn't it? I'm just making this up. Let's say this is 20 degrees right here. That's 20 degrees. What would this angle right there be equal to if I knew this was 20 degrees? 70. Where'd you get 70 from? The right angle is 90. That's right. So altogether, all three of these add up to what? 180. 180 minus 90 is? 90. 90 minus 20 is? 70. So that angle right there is 70 degrees. Okay? We've talked about this, but whenever you have a right triangle, these two acute angles are always complements of each other, which means these two always add up to 90 if you have a right triangle. Okay? Let's do another thing. Here's something else that's true about a rhombus that is not true about all the other stuff that we've talked about. Wonder if I want to even try this. Yeah, let's give this a shot. We got some time. Let's go to red again, and watch what I'm gonna do. I'm gonna start here. I'm gonna go to here. All right, and then I'm gonna go down to here. All right, and I'm gonna copy that, and then paste. There we go. See what I just did? Okay, I took that red angle right here and I just copied and pasted. I want you to see something. And let's group it together so I can work with it as one thing. Watch. If I took this and then actually, let's see how I want to do this. I don't know. Let's not worry about that. Let's worry about what we're doing right here. Okay. Watch this. Let me see if I can figure this out. What if I did this? Put it right here, and then swing this thing up. Let's see if I can. I haven't tried this yet. So, it's close enough. Let's swing it where it's. Oh. That's pretty. I'm concentrating on this. Why are you going to be talking about stuff like that? Look at this. Now I've done it. Look. All I did was rotate it. Okay, I didn't change the width of the angle at all. Would you agree with that? All I did was just rotate it around. So if I took this, that's this angle right here. All right, it's that red one. If I took this and see if I can grab it again, and I moved it right here like this. What's true about those two angles? They sit right on top of each other. So if this is 20 degrees, what's this one right here? That's 20 degrees as well, isn't it? All right, let's just get rid of the red. Alright, so I did all that just to show you this, that if this was 20 degrees, let's turn this back into yellow, then what's this one right here? That's 20 degrees. So what do you think is true about that diagonal? What does it do to that angle right there? Say it. It bisects. Very good. It bisects this angle. So look, remember what we said about the opposite angles. The opposite angles are equal to each other, correct? So what's this whole angle up here? It's 40, isn't it? That whole entire angle is 40 degrees. What's this whole entire angle down here? It's 40 degrees. And guess what each one of these are going to be? They're both going to be 20. That's right. You see that? Because look, I got parallel lines cut by a transversal. This angle up here is going to be this angle right here, isn't it? Alternate interior angles. I got parallel lines cut by transversal. Then this one here and this one here are going to be equal to each other. Everybody see that? So there you go. So let's keep going with this. What if that was 70? What's this angle right here going to be? That's going to be 70. What about these two down here? What are they going to be? They're both going to be 70, right? The whole thing's going to be 140, but both of those are going to be 70, right? So that's something new that we haven't had before. And it's all about a what? A rhombus. So what are the two new things? The diagonals of a rhombus are perpendicular. That's the first new thing that we've learned. And then the second thing is that the diagonals bisect the opposite angles. I'll just shorthand that. The opposite angles. You see that? These two angles, they're opposite each other. What does that diagonal do? Splits them right in the middle, doesn't it? If the whole thing's 40, it splits it into a 20 and a 20. If this whole thing is 140, this diagonal splits it right in the middle. So that's 70 and 70. That only happens with what kind of a figure? A rhombus. That only happens with a rhombus. It does not happen with any rectangle, with just a normal rectangle. It doesn't happen with just a normal parallelogram. It only happens with a rhombus. You writing all this down? You're going to have to go through and just go over this stuff. If you just sit there in class and do this, which is what I'm seeing, okay, and just hands folded, hands on your chin, if that's all you're doing, then you're not going to get this stuff. You've got to take some notes on this, plus you have to review those notes. You have to review your notes. Go to the YouTube videos, for goodness sakes. That's the best thing in the world that you could go to and just sit and just watch me go through this again, and it'll be a reminder to you, and it will stick in your mind so much better if you go back and you review these videos. I'm telling you, it's going to be a huge help to you if you do that. All right, so you've got to do it. It takes extra time, it takes effort, right? But you have to put out that extra effort to be able to understand this stuff. I'm throwing a ton of information at you in these last few days about rectangles and parallelograms and rhombus and all this kind of stuff. Right? You got to keep up on it. You can't just use class time and say, okay, I'm going to sit there, you know, and try to pay attention. It's warm in here. It's a little bit dark in here. It's after lunch. It's a worst case scenario. It really is. You've got to force yourself, if you're not getting it in class, that you're getting it outside of class. Brett, what were you going to say?
I was going to say, I think I like Connor's videos and these.
Good. Well, then watch them. All right, let's do another one. I'll use this thing right here. What do you think that thing is? You sure? Can you say 100% that's a square? You can say it's quadrilateral because it's got 4 sides, but we don't know anything about it being a square just yet, do we? All right. In order to make it a square, let's write that down. In order to make it a square, you got to have a couple things that are true about it. All the sides are equal, so what does that make it? If all the sides are equal to each other, what does that make it?
Parallelogram.
Yeah, it does make it a parallelogram, but something we just finished talking about 2 seconds ago. It's a rhombus. It's a rhombus. Okay, so it's so a square is actually a what? A rhombus. So all the stuff that's true about a rhombus is also true about a square. That's right. But that's not the only thing about a square. What else do you think is true about a square? The angles are equal. Yeah, all 4 angles are equal, which makes them how many degrees then?
90.
All 90 degrees. Well, all of them add up to 360, but each angle is meant to say, is 90 degrees. That's exactly right. So those are the things that are true about a square. So let's list them. First of all, I'll tell you what, we'll just say this. We'll say 4 equal sides. Make it easy. Okay? And then what? Yeah, you can say 4 equal angles. Let's say it like this. And that would be good enough to say 4 equal angles, but we'll make it a little easier for us and just say 4 right angles. You got it? Now, if they're all equal and there's 4 of them, they all have to be right angles. But I'll just make it a little easier and just say they're 4 right angles. So that's true about a square. Now, so a square is actually 2 things. What is it?
A rhombus.
If the 4 sides are equal, that makes it a rhombus. And if all 4 angles are right angles, that makes it a rectangle. So a square is actually a bunch of stuff. And all of these, the rhombus, a rectangle, they're both what? They're both parallelograms. That's right. So it's a quadrilateral, it's a parallelogram, it's a rhombus, and it's a rectangle. I bet you didn't know that square was so special, did you? So all the stuff that's true about all those other things, a parallelogram, what was the next one? A rhombus, a rectangle and a rhombus. All the stuff that's true about those are also true about a square. All right, so let's do this. Let's put another color in here. Let's draw some diagonals because there's a bunch of stuff we know about this with the diagonals. All right, so let's take a look. Facts, do they give you any? Let's see if I have an example or anything. They don't really give you a good example with a square in here. Let's do this. Let's say this right here is 3. And I want to find like all the missing stuff, all the missing parts. So we'll call this A, B, C, D, and call this point right here in the middle, call this E. So I want to find all the angles, I want to find all the sides, all that good stuff. Okay? So what do you think? Where do we start? Well, it's a square, so we know all four angles are all four sides are equal to each other, and all four angles are right angles. So we don't really have to say that because they tell us it's a square. What can I say about AE? If this is 3, without doing any arithmetic at all, what's AE going to equal? It's going to be 3. What else is going to be 3? Do you see anything? The other two, which are what? Give me DE, so that's 3, and then CE, that's 3 as well. Agreed? What's true? What's DB? What does DB equal to? That's easy. It's 6, right? Okay, and then AC must be 6 as well. Because remember, it's a rectangle. What's true about the diagonals of a rectangle? They're equal to each other. They bisect each other also because it's a parallelogram. So if that's 6 and this is 6, then that's 3 and 3. That's 3 and 3. You getting all this? Just repeating it over and over and over again. What about the other sides? What about AB? That's probably one of the harder ones to find. Okay, what about AB? What would that be equal to? Well, first of all, look where angle E is. Do you see this E right here? What kind of angle is that?
It's a right angle.
How do you know it's a right angle? Because a square is also a what? A rhombus, and what's true? They're perpendicular. That's right. Okay, so I'll put a little right angle symbol there. So how am I going to find AB? What am I going to use? What is my tool that I'm going to use to find AB? The Pythagorean? Pythagorean, right. It's the Pythagorean Theorem. Let's write that down since you butchered it. Pythagorean Theorem. Okay? It's named after a dude named Pythagoras way back. Okay? So look, what do we have? We'll call this, well, we'll just call it X. Alright? So we take the two sides, that's the A and the B. So you take 3 squared plus 3 squared, and that equals what? This whole thing. What do I call that whole thing? I just called it X. So call it X squared. You can call it AB, but I just called it X. So what do we get? 9 and 9, which is 18, equals X squared. So X is what? Square root of 18. You could throw that into a calculator if you wanted to. It's 4 point something. Am I right, Joe? 4.2. Okay. So we'll say 4.2. So that's what X is equal to, 4.2. What's BC equal to then? What's DC? What's AD? You get it, okay? Alright, so I think we covered all the sides, didn't we? That's it. I didn't leave anything uncovered. What are we missing? I do have one angle, that's a right angle. The other angles, so watch this. Remember, this is 90. What does the diagonal do? It bisects it. So if this whole thing is 90, what's this angle right in here? Angle ABE. What is it? It's 45, right? It's half of 90. So that angle right there is 45 degrees. What's this one here? 45. In fact, what? Boom, boom, boom. All these in here are all 45s. That's what's true about a square. Okay? Bet you when you're a little kid and they talked about a square, you had no idea that you would know all this stuff about a square. It's pretty amazing stuff. So a square is kind of like a combination of all the stuff that we've been doing right here. Okay? And I believe that's it. How about that? That wasn't so hard, was it? Do you think? You got to go back and review though, because a lot of this stuff does all kind of jumble up in your head, especially when you're sitting in class. Go home, put some headphones on. That's how I would do it. Okay? Put some headphones on, sit there and watch it, And take some notes if you want, or have your notes out in front of you that you took in class. All right, a lot of the stuff, when you zoned out today, because everybody does at some point, don't they? You zone out a little bit? Sure. Whatever you missed zoning out, when you go and watch that YouTube video, hopefully it'll come back in and you'll be able to catch everything. All right, so I'm telling you, it's a great resource, and we're not taking advantage of it like we need to. All right? Okay, I'm going to give you a worksheet, and then that's it.